Alright, I wanted to take a little bit of time to go over the quiz from the 9.5 to 9.7 lessons. It was worth 11 points, number 3 was worth 2, and number 7 and number 8 were both worth 2. The rest of them were worth 1 point. Problem number 1 is finding the value of c that completes the square. Remember, when we do that, we take the b value, divide it by 2, and then we square it. So 14 divided by 2 is 7. 7 squared is 49. So the correct answer was D. Problem number 2 says to use completing the square to determine which of the following gives you the solutions to x squared minus 24x plus 40 equals 28. Remember, with completing the square, we want to have the c term on the other side of the equation, and so when I did that, I subtracted 40 and I got negative 12. And then what you're going to do is you're going to use that b over 2 squared to determine what the c value is that you add to both sides of the equation. So negative 24 divided by 2 is negative 12. Negative 12 squared is 144. So I added 144 to both sides. When I added the 144, that made a perfect square trinomial, so I factored it to x minus 12 quantity squared. And then when I added the negative 12 and the 144 together, I got the square root of, 132. Then I take the square to both sides, and so I get x minus 12 equals plus or minus the square root of 132, and that simplifies because 4 goes into 132 33 times, so the square root of 4 is 2, so it ends up being 2 times the square root of 33. And then I add 12 to both sides, so I get x is equal to 12 plus or minus 2 times the square root of 33, which is answer choice C. Now, number 3 is asking us to write the function in vertex form and to determine from vertex form what the vertex is. Now, we want to do that by completing the square. So when we complete the square, we have to first make sure that we factor the 3 out, and we have to make sure that we move the 71 to the other side. So first I subtracted the 71 to the other side of the equation, and then I factored the 3 out of the 3x squared and the negative 30x, which left me with 3 times x squared minus 10x. Then I used this negative 10 to do b over 2 and square it. So negative 10 divided by 2 is negative 5. Negative 5 squared is 25. So I add 25 to this side, but what I need to do on the other side is actually add 75, because that 25 is being multiplied by this 3, and so I add 75 to the other side. When I simplify that, I get 4. When I factor this perfect square trinomial, I get x minus 5 squared. And then I need to subtract the 4 back to the other side to get this into vertex form. So 0 equals 3 times the quantity x minus 5 squared, and then minus 4. So that is the equation in vertex form, and that means that the vertex is 5, negative 4. Alright, problem number 4. How many real solutions does the equation 8x squared minus 10x plus 15 equals 0 have? So we use the discriminant in order to determine this. Remember, the discriminant is b squared minus 4ac. So the b is negative 10, the a is 8, and the c is 15. So I square the negative 10 to get 100, and then I multiply negative 4 by 8 by 15, and I get negative 480. Because 100 minus 480 is negative 380, that means that this equation has no real solutions. When the discriminant is negative, that means there's no real solutions. On the back, we want to use the quadratic formula to solve the equation. So I listed out my a, b, and my c. My a is negative 4, my b is negative 12, and my c is negative 9. And then I plugged those in to the quadratic formula. When I did that, I got negative 12, plus or minus the square root of negative 12 squared, minus 4 times negative 4 times negative 9, all over 2 times negative 4. When I simplify that inside the square root, I actually get 0. So it ends up being positive 12 plus or minus 0 all over negative 8, which simplifies to just 12 over negative 8, which is negative 3/2. Number 6 is asking which of the following is a solution to the system below. So we're looking at those ordered pairs where those two graphs intersect. The correct answer is D, 2, 0. And number 7 and 8. Number 7, we're using elimination to solve the system. So we actually need to multiply. I multiplied the second equation by negative 1 to get negative y equals negative 9x plus 20. And then I combined these. So I got 0 equals x squared minus 12x plus 36. And use that to actually as a perfect square trinomial to get x minus 6 squared equals 0. So that only has one solution, x equals 6. I use that 6 to plug it into an equation to figure out my y value, and the ordered pair 1, that is the solution, is 6, 34. Now, if we use substitution, what we're going to do is actually set both of these equations equal to each other, and then I need to move them to the other side so that they are equal to 0. So I add the 2x and I add the 19 to both sides. Oh, sorry, I subtract the 19 from that side, and I end up with x squared minus 5x minus 24 equals 0. That factors, I can multiply negative 8 and 3 to get negative 24, and when I add that together it gives me negative 5. So my two x values are x equals 8 and x equals negative 3. Then I take those values and plug them back into my equation, and when I plug in 8 I get out the number 3 for my y, and when I plug in negative 3 I get out the number 25 for my y. So my two solutions are the ordered pairs 8, 3 and negative 3, 25.